listening to Claes. Welcome.
Okay, so thank you very much for taking the time to join this webinar. And we are going to talk about machine learning, digital twins to optimize and improve reliability of HVAC&R systems. Let's see, so I get this to move. And so just we start with a little bit of background for those that might not know as well since before. And we'll take a discussion on some experiences and what can be achieved by performance analytics and the experiences from some cases. And just showing how much energy that can be saved. About 20% of the global electricity is used by refrigeration processes in cooling, refrigeration, and heat pumps, dehumidification, and such. So these systems are wasting about 25% of the energy, based on our experience and many other surveys that have been done. They are basically not operating as well as they can. So there is going to take place a paradigm shift in the next coming years. So we can really enhance the efficiency of the systems, and most failures can be avoided. They don't need to take place if you correct issues when they start occurring. And machine learning will be really a game changer in this, as it reduces the engineering hours that is required and make it possible to much faster come to the conclusions in the systems. Of course, there are still issues on the market, with many equipment owners not being aware of the potential and looking more on the initial price than operating costs. So first, we need to conclude that to maintain a temperature, that's not the same as good performance. It's extremely big difference between achieving the temperature and doing it efficiently. And just a little bit about ClimaCheck. I mean, I started with performance analytics in the mid-80s. I was studying thermodynamics at the Royal Institute of Technology, and there was a heat pump boom in Sweden, and I got involved with maintenance and troubleshooting on heat pumps. And methods that was used with flow-based measurements and power meters and temperature difference, that was very difficult to use in the field to prove efficiency in dynamic systems. Flow measurements are costly. They are difficult to get accurate in a dynamic system in the field. You're working with small temperature differences. So it was not efficient to get the performance. But even more, if you found that the performance was not what you expected, you had to start the troubleshooting to find the cause. Whereas if you go from the thermodynamics, it should be possible to define the problem from start and address that much more easily. So there was a performance analysis on the market since then. But then 2004, I've been in other areas of the industry and felt that now there were laptops and these type of things that weren't available in the 80s. And it was time to focus on this again. And so I started ClimaCheck together with a programmer, and we realized quickly, it was already 2007, that online will be the future. So we launched ClimaCheck Online. There are still portable inspection tools on the market, but the online monitoring is, of course, going to play a more and more important role. And when it comes to the development now, it's focused on, of course, enhancing the visualization and analytics as such. But the big thing is, of course, the machine learning, and use that in an efficient way. We have continuously been involved with development work with research institutes, both in Sweden and internationally. So we try to always move forward. And today we have more than 100 man-years of experience of troubleshooting and optimization, and a large network of distributors and partners all over the world. And also we have achieved quite a bit of international recognition. As the table here shows, this is from the National Renewable Energy Laboratories evaluation of automated fault detection and diagnosis systems available on the US market. And there is a lot of well-known brand names, Carrier, Train, Johnson Control, and people that have been working in the industry for long. But the only company that reaches level 3 in their evaluation was ClimaCheck. And this is because that we can pinpoint the problems to the component in the system, which is unique for us. Also, the International Energy Agency Annex 52 developed guidelines for long-term monitoring of it's aimed for ground source heat pump systems. That means chillers and heat pumps working with ground source. But this is applicable for all types of systems. It's not really important for the monitoring technology if you have what the heat source and heat sink is. The strategy for monitoring is the same. So I recommend Annex 52. In the presentation, you can click on the document, and there will be a link for that. It has both guidelines for instrumentation and data, and it has also uncertainty calculations. It covered the internal method, which is the ClimaCheck method. We have also, during the last year, focused on the machine learning aspect, and we have done 2 master theses that has, together with the Royal Institute of Technology in Stockholm, that has proven extremely efficient on the internal method. As we have all the models we are working with is based on thermodynamics. So it's physical models where we know which factors are impacting the performance of the system. So we know exactly which parameter we need to let the digital twins be trained on. And we have a huge amount of data from thousands of sites, and time series all the way back to 2007, and covering virtually any application available on the market for air conditioner and refrigeration and heat pumps. So it has proven to be even more powerful than and less challenging to get results from than what we had hoped. And this work is now continuing. We have received a research project from the Swedish Energy Agency that is together with the Research Institute of Sweden and Halmstad University and Vasakronan. That's one of the largest property owners in Sweden. Sorry. Excuse us, there was a phone call coming in on the computer. Excuse me. But yeah, Vasakronan is one of the largest property owners, and they, of course, are focused on energy efficiency and reliability in all their chillers and heat pumps. So they're coming from the end user perspective and participating in the project. Enrad is a chiller manufacturer focused on propane chillers and heat pumps. So they're coming from the OEM perspective, and they are also implementing ClimaCheck as standard on all the units they supply to the market to ensure that they have the best performance and they are correctly commissioned and avoid warranty issues. And just some examples of results that have been achieved. This is from Banner Health, a hospital chain in US. They first started with a pilot on 10 hospitals, and they recommissioned the sites based on the ClimaCheck analytics and achieved very significant savings, almost $4 million US dollars per year. And the good thing with this project is that they followed up also after the recommissioning and the improvements of the system. And what they identified and have been really focused on after is that there is always things happening. So in 6 months, they had 24 issues that were identified on these 10 hospitals. And many of them cause 10 to 15% increased energy consumption, but some are even up to 40%. And by detecting these when they are emerging, they could save an additional 130,000, they avoided to spend 130,000 per year by that monitoring. And what is interesting in this project is also that they continue to follow up, and during 2019 till 2021, they monitored these 78 chillers when they had installed on all the 25 hospitals. And they identified 109 new issues, and they registered which type of problems they identify. And there is a wide range of problems. So it's not one thing that you can avoid. You have to keep an eye on the whole system, and some are coming from the control side, some are coming from internal in the chiller, some are coming from the distribution or cooling tower system. So you need to keep an eye on all the aspects of a chiller or heat pump. And they also could identify that the maintenance cost decreased with 9%. So when we're talking about 25 hospitals, that's quite a significant saving. And Bernard, the engineering company that is supervising these hospitals, they maintain 1,600 hospitals in US. So if you extrapolate the savings in these hospitals, it's enormous amount of money and energy. Another, by this time quite old, but well-documented case was the Sands casinos in Macau. They have more than 300 megawatt of cooling in 3 casinos, and they achieved also significant savings by ClimaCheck monitoring and optimization of the system. So this report is come from the ASHRAE Energy Award 2018. And this is from a shopping mall in Sweden, where they actually reduced the energy consumption for air conditioning during May, August 2022 compared to earlier years with 50%. And this was without replacing any hardware, same chillers, same pumps, same system. It's a aquifer system where they take heat out of the groundwater in the winter, and in the summer they heat up the groundwater. And the main issues here were related to the controls. There was a number of faults in different components and parts and so on, but the main issue was the controls, which is very common in many chiller plants, that the controls are not stable, and it's cost. It increases the wear on the system drastically, and it reduces the energy efficiency. In this case, they had a lot of issues with oil return from the system because of the compressors were at times, certain conditions, they were short cycling, leaving the oil in the evaporator and tripping. So this is before and after they fixed the controls. So after they had fixed the controls, there were no tripping on the chiller at all. This is after they've been running these chillers. It was detected that the condenser efficiency on one of them were decreasing, So they cleaned this condenser in October this year, and there was a clear improvement. And this condenser fouling caused the increased energy consumption of about 7.5%. So now they detected it early, could clean, avoiding high energy consumption. Another indication on that the market is starting to focus in this area is this is a project we did for the German Energy Agency. They identified that there was no movement on energy efficiency in the refrigeration market because everybody expected that if the system cooled down the goods, then they would not do anything because they thought it was working good and also expected to be efficient. So they launched a request for proposals to establish a benchmarking platform. So ClimaCheck, together with PropTech OS, who is a database platform to, in a structured way, according to the real estate core standard, collect all the data from the properties and make it available for analytical purposes, such as ClimaCheck. And together with Analyse, our distributor in Germany, we quoted for that project and was awarded the project in 2022. So then we have until mid this year, we built a pilot for this platform for benchmarking, and it basically is using the ClimaCheck method and the system efficiency index, the sub-efficiencies for components, and also the energy signatures that we have been developing since long, but also adding normalization. So we look at energy signatures per square meter for buildings, or cubic meter for cold stores, or for example, in some supermarket chains, they look at the meter display case, where they convert low temp display cases to corresponding meters of medium temp, and cold rooms the same to a corresponding meter of display case. So they get a reference that is better describing the supermarket's refrigeration system than if you just look at square meters. So you can say that this platform is focused on benchmarking, but it also have complete information for automated fault detection and diagnosis. So when we then go to the automated fault detection and diagnosis, we can monitor all these KPIs. I mean, we have all the information, the same as in a test rig in a manufacturing factory where they build chillers or heat pumps. We have all that data in real time in the field. So we can put early warnings when any of these parameters deviate. And that, of course, is together with the energy signatures, where you can evaluate what the influence is. It's extremely powerful. And here it's used for peak shaving, which is another aspect. We want to move the energy consumption to when the electricity price is lower and the grid is less strained. And this is, of course, going to be more and more important in the future, where we see that wind and solar is playing a more important role. We will have more fluctuations in electrical prices, and we want to move the energy consumption to when we have more supply. So this was done together with ICA, the biggest supermarket chain in Sweden, IKEA, and the Research Institute of Sweden, and Caverion, which is a large contractor here, where we looked at the commercial refrigeration, how you can move energy by planning the operation. So basically, you can say that we run we change the set point during night. So we have a lower temperature in the display cases. And then when it comes to the critical hours in the grid, which is 8 to 12 here, normally in Sweden, we can run with lower consumption as we adjust the set points upwards, and we limit the available capacity. So it was actually possible to reduce the load during the morning hours to 50% of what it was before. And it was also resulted in that the energy consumption decreased quite significantly. One part of that was the optimization, based on that we evaluated all the KPIs and the controls and adjusted the system. But it was also a significant impact of that during nighttime, it's a lower temperature outside. So even running at the lower evaporation, it was still beneficial to run more at night than during the day. So this is going to be, I think, important on many markets, and not only in commercial refrigeration. It will play a big role also in air conditioning and heat pumps. So I'm not going to go through the method in detail, but it's based on thermodynamics. It's well described, and it's well proven today. And then we get all the KPIs. This dashboard is the perfect service protocol. It contains all the KPIs that should be checked at the service inspection. And every parameter can be monitored 24/7 online to detect deviations. And then you make energy signatures. Because of air conditioner refrigeration sites, they follow normally the load, follow the outdoor temperature, as well as the performance. So in most sites, you have a close correlation to outdoor temperature on your energy consumption. So this means that we evaluate performance on component and unit level, and then we see the result on the energy signature. So by monitoring this, we can both have this as a warning. We train the server to know what is expected at this temperature of this specific site, and then detect deviations. And it's also extremely powerful when you want to evaluate result of optimization, because you can really see what happens, which is not easy if you try to compare different time periods, because the different time periods will not be identical when it comes to temperature. Another aspect that is extremely important in our systems is the controls. We have controls in the units, and we have controls in the system. And these are very rarely tuned well together. Somebody is responsible for chillers, somebody is responsible for the BMS, somebody is responsible for the distribution system. These need to be checked and commissioned together. This is something that is very common. We have a system. The gray line is the power, and we can see that at night the power goes off and on. So they actually not only one compressor starting. So frequently one compressor starts, a minute or two later another compressor starts, and then that is too much capacity, so it stops. So the response, the system is the control is too aggressive. And this is extremely common. And in this site, there are variable speed drives. So there should be no necessity whatsoever to run it like this. And it kills compressors. So here is another example of poor control. Here they actually didn't do anything in spite of several reminders from us until 2 compressors failed. Then they adjusted the controls. So there's no change except for replacement of the failed compressors between the left and the right picture. besides adjusting the controls, they did not cause start-stop. And there are, as mentioned before, there are many issues that can cause problems in a refrigeration, air conditioning, heat pump system. So you need to systematically make sure that your controls are working well, correct refrigerant charge, and flow balance, condenser, evaporators, fans, pumps, compressor. So it becomes quite complex, and this is where we want to run these systems over a wide envelope of operating conditions and over different capacities. So this is where it becomes really a game changer when we can use digital twins. Because if we have a digital twin, we can know the digital twin tells us what should this system do at this specific operating conditions and load. If we don't have a digital twin, it requires time and effort from an engineer with experience to set up the limits. You don't want to have too many early warnings, and you don't want to miss one. So you need to tune your settings according to the site. This is absolutely not impossible, but to do it on hundreds of millions of systems globally, it's going to be impossible. There is not competent engineers, and it's time consuming. But with machine learning, you can train digital twins, and you don't need to train on every system because of compressor will behave the same in any system that compressor is installed at the same pressure conditions and suction temperature. It will do the same thing every time. And you can even say that most screw compressors will behave the same, or not the same, but similarly, unless some are variable speed drive. You need to have a digital twin for that. So you can train digital twins for groups of components. And here you can see that the blue is the measured condenser efficiency on a unit. The yellow is what the digital twin predict based on training on another system, but the same design. So you can see how well the clusters are following each other. And here we have 4 clusters. It's full on part load. The efficiency is better at part load. So the upper cluster is part load, and the lower is full load. In the right-hand 2 clusters, they are heat pump operation, and the left cluster is air conditioning. So you can understand how much easier it is to set limits on deviation from the digital twin versus setting limits based on the 4 clusters. And if you look over time, you can see that the digital twin is predicting extremely well the measured value. So it becomes very easy to give the tolerance to the digital twin, which makes it much more accurate and much easier to apply than setting the limits as thresholds. And this is just an example showing the spread between these 2 systems. You can see that there's approximately 1% difference between these 2 systems, and the spread is very small. So it becomes very reliable. And here we are looking at one parameter, the subcool, which is a very good indicator for refrigerant charge in the system. So you can see that both the blue and yellow, they have a spread of 3 to 4 degrees between different operating conditions. So if we want to detect a deviation, a 1 degree deviation would indicate a change of refrigerant charge. It becomes much easier to monitor versus the digital twin rather than using conventional threshold limits. This is showing on compressor efficiency. There is an issue occurring on thousands of systems every year where there are tandem compressors here, where there is actually two different issues that cause the same symptom when you look at compressor efficiency. Actually, here we see that when one compressor stops, then the compressor efficiency seems to be 100%, which is not possible. This means that we get refrigerant liquid into the compressor. There are actually two different causes in this case. One is leaking check valves in one of the tandem scrolls, or that the expansion device do not operate correctly at low load, that you can get some liquid carryover that is not actually registered by the sensor for the expansion device, but it's in the bottom of the pipe. There can be some liquid, and that comes back to the compressor and dilutes the oil, and you get compressor failures. And you can see this immediately when it occurs, which is, of course, then easy to fix at that time at much lower cost than if you let the compressor run to failure. This is another application of using digital twins. This is actually two different chillers that have been competing on many projects. So I know that sometimes they have bought one of this type of chiller and sometimes the other. The yellow is the digital twin trained on a high-performing chiller, and the lower is the measured value where they have selected a lower performance chiller that is also cheaper. So it might make sense to buy a cheap chiller, but you should understand that the difference here is 50% on energy consumption. And this is the comparison is running taking the conditions, exactly the conditions of the blue chiller, and what would the yellow chiller do in that condition. So you see how actually the impact would have been on this system. And today, almost all the sensors are already installed as standard. Some chillers, they are missing one temperature sensor on the liquid refrigerant liquid line between condenser and expansion device, which is easy to add and it's even easier if you add it from the beginning. Sometimes we recommend that you structure the power measurement different than what will be default. But today, most of the data we get from APIs. That means that it's third-party hardware. We don't supply sensors. We get the sensor data either directly from APIs, server-to-server communication, or through a gateway. That is, the BMS writes data with Modbus to a gateway, and the gateway communicates to our server. But still, there are, of course, a lot of applications where it would be, even if the sensors are there, it can be challenging to work in old BMS systems and so on to get the data. So there's a huge number of systems that need a standalone to make installation easy and predictable. But sensors are there. That's not the issue. So, of course, the change will be driven by request of more sustainable business and more cost-effective business. It is extremely cost-effective with predictive maintenance, both reducing energy consumption and reducing failures. But of course, the equipment owners need to understand that they are required to specify that they want predictive maintenance, and they need to pay more initially to save energy and failure cost later. Of course, you also need to push the industry. If the industry is not seeing a business opportunity in building competence and experience, they will not do it. So it has to be requirements from customers, and the industry need to build competence. Of course, there are companies now that have started and realizing this, but we are in very early days in the transition to predictive maintenance. And of course, now when we are starting to implement AI, machine learning, digital twins, it's going to also improve our capability of pinpointing the problems even further, because we can compare, use all the KPIs we have to do fault trees and eliminate a number of possible issues automatically in the system. There will always be some need for local expertise, but they can build experience extremely quickly by being supported by digital twins and automated fault detection and diagnosis systems. And this is necessary as we have hundreds of millions of systems that need to improve energy efficiency and reliability. So this was a introduction to what we see is coming. We are now beta testing our next generation platform, where AI and machine learning will be integrated. So during the next year, we will gradually transit over to the new platform when this is all integrated. Currently, we're using AI and machine learning running on the data we have on the current server, but we are running it, on the side, on a separate platform. But this will come into real application during next year, and it will be, and of course, much enhanced in the research project that we are doing together with the research institutes now, and of course together with customers and partners. So I hope there are some questions.
Perfect. So if you have questions, just raise your hand or write them in the chat, then we will answer them.
It was either totally crystal clear or totally not possible to understand anything.
Yes. Michael, you can unmute. Oh, hi.
Hi. Yes, thank you, Claes. Can you tell a little bit more about the digital twin? What do you mean by the digital twin?
Yes, for everybody who don't know Michael, I can tell he is one of the researchers at is Research Institute of Sweden. So he's an AI expert. So yeah, what we have been implementing so far, and it's neural networks that we train on data from existing sites where we have a lot of data, overall operating conditions, where we have judged that these systems are running well. So we use those for training, and then of course the digital twin then replicate with the parameters that we have told it that these are the factors affecting the condenser efficiency, evaporator efficiency, compressor efficiency, system efficiency index, subcool, superheat, all the KPIs that we have defined as important. Using the same input in the when we train the digital twin, of course, and when we test it on you. Did that explain? I think that you know much more about neural network technology than what I do.
Yes, it's essentially a neural net model which emulates the system.
Yes.
Then we have from Tom, what will be the first functionality of machine learning for automated fault detection and diagnostics that you plan to roll out?
I mean, it will be the type of where we instead of setting thresholds for example, for subcool, as we do today, we set threshold for subcool, for condenser efficiency, compressor efficiency, and so on. Instead of using thresholds, we will in real time we will have what the digital twins predict. So we have a prediction of the performance on each component every minute, and then we will set limits on accepted deviations, which makes our life for setting up early warning extremely much more efficient. So basically, we are also, I mean, we are one big issue in the industry today is that they are generating too much alarms systems. So you have some sites where they have continuous alarms on everything and nobody cares because there are too many, and you have other systems where there's no alarm sets because it's too much nuisance to have alarms. The advantage we have here is that they're extremely specific, and by allowing a deviation from the prediction, they become more accurate and allows to detect earlier deviations without false alarms. So this is going to be implemented gradually during next year.
Perfect. I think we don't have more questions. I will turn off the recording and thank you very much